This is going to be a long video, so let's not waste any time. If you're watching this, I assume you're interested in self-hosting, and you have some experience and familiarity with the concepts, but you're not sure how to really put everything together and get things up and running. This video is basically a step-by-step guide on how to do that. Before we get started, there are a couple of things to keep in mind. First, there are a lot of different ways to do self-hosting, and lots of decisions to be made. What I'll show you here is just what has worked for me. For example, I've spent a lot of time researching and tinkering with things like Kubernetes, Proxmox, Cloudflare tunnels, and so on, but you won't see anything about those here because for one reason or another, I ended up deciding not to use them. I'm also going to be exposing self-hosted services directly to the internet instead of using something like Tailscale or WireGuard. You can watch my last video to learn more about why that is and what to know about the risks involved. Second, a self-hosting tutorial necessarily needs some background knowledge. So while I will provide some short explanations of terms here and there, really, I assume you already know the basics of networking, containers, and Linux. Because if I tried to explain every little concept from scratch, this video would be hours long. This is more of a practical tutorial or how-to guide than a conceptual explainer kind of video. So if you're not that familiar with things like internet domain names, cloud service providers, ports, firewalls, SSH, containers, Docker volumes, Docker networks, etc., then you may need to pause the video very frequently to look stuff up. With that out of the way, here's an overview of what we'll be setting up. To start with, obviously, we will need a server to run our self-hosted apps. This can be any computer you have, like an old laptop, a Raspberry Pi, or in my case, this poor machine that has to pull triple duty as a server, media center, and gaming PC. You can, of course, run anything you want on the server. There's a ton of self-hosted apps out there for pretty much anything you might want to do. Really good stuff like Image, Jellyfin, Home Assistant, etc. But for this video, I'll use the File Browser app as the main example. File Browser is a very basic but very reliable Dropbox or Google Drive alternative. Just like pretty much all the software we'll see in this video, File Browser will run in a Docker container. In order to make File Browser accessible from the outside world, we will need to buy a domain name. In my case, the domain is imranr.cloud, and then we'll point that domain name to our server, so that when I open files.imranr.cloud in my browser, no matter where in the world I am, I'll be able to access my files that are on the server at home. Speaking of access, the simplest way to expose your server to the outside world would be to use the port forwarding feature on your router to open up some holes in your firewall and let outside traffic in directly. But this isn't always possible for various reasons. Maybe your internet service provider doesn't allow it, maybe you're renting an apartment where you don't have control of the main internet router, etc. In that case, you'll need to find some other machine that lives somewhere outside your home network where it can accept traffic from the outside world. You can get one of these for a few bucks a month from any cloud service provider. That machine will then accept requests from the internet and tunnel those requests into your machine at home. And this is the approach I'll be going with. Even if you do have the ability to forward ports on your home router, you might still want to use a proxy server anyways, because it also has the side benefit of hiding your home IP address from the outside world. The specific software we'll use for this is called FRP. We'll have the FRP server app running on the cloud machine and the FRP client running on the home server. So to make things simple, I'll just refer to these as FRPS and FRPC. Okay, the picture so far looks pretty simple. We have a domain name that points to a low-powered cloud server, which in turn uses FRP to tunnel requests to a high-powered machine at home that actually runs all of our self-hosted apps. But there are a couple of problems here. First off, the File Browser app just listens for HTTP requests. It does not handle encryption for HTTPS, and the same will be true for the vast majority of apps that you'll ever come across. Obviously, this is unacceptable. We must have HTTPS for everything. The second problem is that even if we could set up HTTPS for the File Browser app, what happens when we decide to run a second app on the same server? If they both use HTTPS, then they both must listen on port 443, so there is a conflict there. With the setup as I'm showing it right now, it would only ever be possible to run one web app or service at a time, so we need a way to fix this. Both of these problems will be solved using an app called Traefik. Traefik will run on the home server, also in a Docker container of course, and it will listen for HTTP and HTTPS requests coming from the internet. We will also set up subdomains and assign each app its own subdomain. So if my domain name is imranr.cloud, then the File Browser app could run on files.imranr.cloud, and some other app would run on some other app.imranr.cloud. So when a request comes in, Traefik will look at the subdomain that the request is for and use that to forward the request to the appropriate container, either the file browser container or whatever other app we may have. So this solves our ports issue. Traefik also solves the HTTPS issue, because with just a few lines of configuration, it will automatically set up and continuously renew HTTPS certificates for each domain and subdomain that we need to use. Notice that we technically have two proxies in our setup. We have FRP running on the cloud server, and we have Traefik running on the main home server. Technically, both of these are what we call reverse proxies, but they work on two completely different levels of the network stack, and they play two completely different roles in this setup. FRP is really simple. It just lets us expose our home server to the outside world. That's all it does. And like I said, if you can do direct port forwarding on your router and you don't care about exposing your home IP, you don't need FRP or this extra subscription-based cloud server at all. Traefik, on the other hand, is where the real magic happens. It's very powerful, and not only does it solve the problems that I just described, it can also be used to do all sorts of other things that I won't talk about just yet. Alright, so this is the final picture of what we'll be building, at least for now. If you watched my last video, you'll know that this setup is still far from complete. I mean, it's functional, but there's still a lot we could do to improve our security and lower the inherent risk that comes with exposing things to the internet. For example, we could set up a single sign-on authentication layer to protect all the apps, we could use CrowdSec to protect from malicious bots, or GeoBlock to block specific countries, etc. But I'll save those for the next video, since this one is going to be long enough as it is. Okay, let's get into it. So I'm here on my home server, and I've gone ahead and installed Docker and Docker Compose on it. You can look up the steps for how to do this on your machine. The OS you use doesn't really matter as long as it's some kind of Linux. I've also created an empty new folder where I'll put all my stuff for this project. And I'll start by creating a new file named server.dockercompose.yaml. This file defines all the containers that will run on this machine. And I'm going to paste a bunch of content into it. All the code in this video is available at the link in the description, but I do recommend that you manually type everything in, just to really get familiar with how all of this works, because it is your setup at the end of the day. Let's go over this line by line. This YAML file format uses indentation for structure. So for example, when you see this services line at the top, it basically means that everything with more indentation that's further to the right is defining a service. And a service is just a Docker container. I have defined a service named file browser, and the container is also just named file browser. These names can be anything you want. I've then specified that this container will use the container image for the file browser app that's available on Docker Hub. Docker images are most often downloaded from the Docker Hub repo, and that's where we'll get this one from. Sometimes you will see images coming from some other repo like GitHub Container Registry, for example. I specified that the container should always restart in case of a crash, so it will only remain stopped if it was stopped manually. Note that this configuration was adapted from the official Docker install instructions for file browser. Pretty much all self-hosted software these days will have an official Docker image and instructions, and in many cases they'll have a ready-made Docker Compose file that you can use as well. Next, we're defining a couple of volumes to mount into the container. Like I said, I do expect you to have some background knowledge, so now may be a good time to look up Docker volumes and the differences between a named volume versus a bind mount. But the summary is that when a container is stopped and started, it loses any data it may have had. So if you don't want all your apps to reset every time there's a crash or a reboot, you need a place where the container can keep any data that's supposed to persist across reboots. That's what named volumes are for. In this case, I have a named volume called FileBrowserDB, and it's mounted to /database in the container. This is where the file browser app will store its internal data, things like user info, preferences, etc. Bind mount is a way of giving the container access to some existing path on your server. Because remember, usually anything running inside a container doesn't have access to files elsewhere on your machine. In this case, I've created a folder called File Browser Storage, and I'm mounting it to /srv inside the container. This is where the actual files that I upload to File Browser will end up. In most cases, it's up to you to decide whether to make something a bind mount or a named volume, depending on the use case, because they both have their pros and cons. One other thing to note is that the user inside the container has a UID of 1000. That's what this line means. That means we need to make sure that all bind mounts are accessible by user 1000. Now, when a Docker container starts, any bind mounts that don't already exist are created as folders belonging to the root user aka user 0. So in this case, having the folder automatically created would result in permission-related errors, because we need the folder to be accessible to user 1000. So I'm going to manually create the folder right now before I start the container for the first time to avoid that problem. Also, if you're using a distro that uses SE Linux like Fedora, you might want to look into the Z and capital Z suffixes that sometimes have to be added to the volume mount lines to avoid SE Linux issues. Also note that any named volumes we use have to be declared at the bottom of the file as well, like I've done here with the file browser DB volume. Finally, I've mapped port 80 inside the container to port 8080 outside. So even though the file browser app listens for requests on port 80, I'll be able to access it locally on port 8080 instead. There's no particular reason I picked 8080, and this line is temporary anyways. We're not going to need it after we set up Traefik later. Okay, let's test out what we have so far. I'll run docker compose in the terminal, and I'll use the -f parameter to specify the file I want to use, server.dockercompose.yaml. And then I'll say up, which means that I want to start the containers. Okay, you can see that it's running, and if I go to localhost 8080 in a browser, we see the file browser UI. The first time that file browser runs, it generates a random password that you can change later, so I'll copy that from the terminal and log in. I can create a file, and I can see that the file exists in our bind mount folder. So it looks like this app works, and we can move to the next step, installing Traefik. Okay, it's time to set up Traefik. I've added a bunch of lines to the Docker Compose file. Note that at every step of this video, you'll be able to tell which lines have just been added or modified by looking at the green or blue markings on the left side. Okay, let's go through the new lines. I've defined a new container up here for Traefik. Just like with File Browser, I've added a container name and a source image. The command section specifies a bunch of arguments that will get passed to Traefik when it starts up. We don't need to go over each line individually, but on a high level, the first few lines tell Traefik to provide an optional web page with a graphical UI, which will show what Traefik is doing. The next line will set the log level to debug, because that makes troubleshooting easier. And the last batch of lines will tell Traefik to accept requests on two interfaces: the web interface on port 80 for HTTP requests, and the web secure interface on port 443 for HTTPS. And I've included a line that tells Traefik to automatically redirect everything from the web interface to the web secure interface, because like I said, we really shouldn't be using unencrypted HTTP for anything. And in the ports section, we're just mapping those ports 80 and 443 from the container to the host. Now, this line under volumes is important. What this line does is it exposes the Docker socket to the Traefik container. The Docker socket is a file which, if you have access to it, allows you to basically do whatever you want when it comes to the Docker install on your system. Traefik needs this in order to work, because it needs to see all the details of all the other containers that are running. Unfortunately, anyone who has access to the Docker socket could in theory get root access to your device and do pretty much anything they want. So you're placing a lot of trust in Traefik, and if this container gets compromised, that could be a big problem. This is a security risk that just comes from using Docker because of the fact that Docker runs as root. Docker does have a rootless mode that you can try to use, or you could even ditch Docker entirely and use Podman instead. But I haven't been able to get either of those options to fully work in my setup just yet. Lucky for us, there is another way to reduce the risk here. It's a piece of software called Docker Socket Proxy, and it basically adds an extra layer of protection by adding a permission system to the Docker socket. I haven't actually tried this yet, so I won't cover it here, but I do intend to do so stay tuned. Further below, we've also applied some container labels to the Traefik container. The labels tell Traefik how to expose that particular container. In this case, we're saying that the graphical dashboard for Traefik should be available at traefik.imranar.cloud, and that it accepts requests on the web secure interface that we defined earlier. You can see that we've also updated the file browser container to depend on the Traefik container, which just means that if the Traefik container fails to run for any reason, then file browser will also not run. File browser also has some new labels which will tell Traefik to make it available at files.imranar.cloud. Now, Docker has virtual networks that allow containers to have some level of network isolation between themselves and the host machine, and it allows each container to have its own IP address so that containers can talk to each other in the same way that they would if they were on a real network. So I've created a Docker network called Traefik, and assigned both of our containers to that network. Just like volumes, you need to declare networks at the bottom of the file, which is what I've done here. I have also manually specified the IP range that the network should have. If you don't do this, Docker will just assign a range automatically, but there is a reason that I've done this, which will become clear later. Now at this point, we have two services defined. The file browser service, which Traefik will make available at files.imranar.cloud, and the Traefik UI dashboard, available at traefik.imranar.cloud. But we haven't actually set up the imranar.cloud domain name yet. We haven't actually done anything to expose our server to the outside world. We will do that later, but for now, just for testing purposes, I'm going to use a trick to make this computer think that those domains exist even though they don't exist yet. I'll simply add those domain names to my hosts file, that's /etc/hosts, and point them to localhost. Okay, let's see if that worked. I'll run docker compose up again, and I'll try to visit traefik.imranar.cloud in my browser. It does complain that the website uses untrusted certificates, but that's normal at this point. We're using the built-in Traefik certificates, and we will fix that later. So I'll just click past the warnings for now, and there you go, it works. And you can see that files.imranar.cloud works as well. Moving to the next step, we now want to expose our services to the outside world. Like I said, we'll use FRP for this. With FRPS running on a publicly accessible cloud server, connected to FRPC running on a home server. We'll also buy a domain name that points to the FRP server so that we can access each app at its own subdomain. So let's start by defining the FRPC container. There's not much new to explain here, other than the fact that this container doesn't run on a virtual network, it runs directly on the host network, because it needs that in order to work. You might have noticed earlier that for the other containers, I just say that I want the latest available version of the container image. But for FRPC, I've decided to specify the version number that I want because I want to be very intentional about which version I'm on and when it gets updated. The command section for this container references a config file called frpc.toml, which we provide to the container as a bind mount. So let's go ahead and create that file. The configuration is pretty simple. On the first line, I'm telling FRPC where to find FRPS. This is supposed to be the IP address of the cloud machine, but we haven't set that up yet, so for now I'm just using a placeholder value. We define port 7000 as the port that FRPC and FRPS will use to talk to each other. We define a secret token that they will use to authenticate with each other. Obviously, you should use a long and random value here instead of what I'm using. Then we're defining what ports we actually want to tunnel from FRPS to FRPC. So for HTTP, we tunnel port 80, and for HTTPS, it's port 443. Any additional ports you may want to expose later will be added to this file in the same way. Now, one thing to note is that when somebody sends a request to one of our self-hosted apps, it's often useful to know what the requester's IP address is. That way we can do things like ban the IP if it seems malicious, or if it comes from a specific country. But the problem with using a proxy like this is that because all of our traffic goes through FRP before it reaches the home server doesn't get to see what the original requester's IP address was. It will only see the IP of the proxy instead. To solve this problem, we use something called the proxy protocol. This is basically an extra piece of information that FRP will attach to all the tunneled or proxied requests, which will contain the original requester's IP, and Traefik will then be able to make use of this information. So that's what lines 14 and 23 are configuring here. We also have to enable proxy protocol support on the other side in our Traefik config, and to do that we have to tell Traefik what the IP address of the FRPC container is. Remember that we had set the FRPC container to use host networking instead of being on the virtual Traefik network. So from Trafik's point of view, the IP address for FRPC is simply the gateway IP of the Traefik Docker network. And that IP is 172.19.0.1, so that's what I've put on this line here. And that's why I manually specified the IP range for the Traefik network earlier. One more thing that I've done here is assigned a new named volume to the Traefik container. It's called Traefik_acme and it's mounted to /acme. This is where Traefik will store information related to HTTPS certificates, and it's going to be useful later. Now that we've prepared the FRPC configuration, we need to do the same for FRPS. So I'll create a new Docker Compose file that will be uploaded to the cloud server that we are going to buy later, and the contents should look familiar. It just has the one FRPS container, and it also needs an frps.toml config file. This config file is pretty simple. We just tell FRPS that the client is going to connect on port 7000, and we set the authentication token, the same one that was set in the FRPC config earlier. Okay, now it's time to actually set up the cloud server with FRPS. So you're going to need two things at this point. First, you'll need to buy a domain name to use for your apps. I've gone ahead and bought imrana.cloud from Hover Domains, but there are a ton of different domain registrars you can pick from, of course. I've also set up a free cloud server on Vultr. And again, there's tons of different cloud providers like DigitalOcean and OVH that you could use. You really don't need anything expensive. Typically, the smallest and cheapest option they have will be good enough. And you can definitely find free ones as well, like the one I'm using. What you do need to pay attention to are bandwidth limits, since all your traffic will be going through this server. Also, now is a good time to mention that these kinds of machines are commonly called virtual private servers, or VPS, because they're actually small virtual machines that are running on much more powerful real hardware. So if you hear the term VPS, that's what it is. So I'm going to SSH into the new VPS I just got, and of course I've made sure that Docker and Docker Compose are both installed on this machine as well. And the first thing I'll do is create the FRPS, Docker Compose and config files that we just went over and paste in the content. Next, we need to make sure that the subdomains for our apps actually exist and point to the VPS. So I'll go to the DNS page for the domain I just bought, and I'll add a couple of new A records, one for traffic.imrana.cloud and one for files.imrana.cloud. We also need to make sure that ports 80, 443 and 7000 on the VPS are accessible from the outside world. Typically, there are two firewalls already in place when you buy a VPS. One firewall running on the VPS itself, and one firewall running on the cloud provider's network. After digging around on the Vultr website, I found that they don't actually have a firewall on their end by default, so that makes my life easier. So it depends on your provider. Now, the VPS itself does have a firewall, and I can use the UFW command to open up some ports. Again, depending on the specifics of your setup, the command you use may be different. So now I'll use UFW to open up TCP ports 80, 443 and 7000, plus UDP port 7000. Then I'll use a port checker website to confirm that the ports really are open, which they are. Also, now that I know the IP of my cloud server, I can put that into the FRPC config so that it's now ready to use. I should also get rid of the lines I previously put in the etc/hosts file, since our domain now exists and we don't need to fake it. Finally, it's time to see if this thing works. I'll run Docker Compose up on the VPS to start FRPS, and I'm using the -d parameter to run it in the background so it doesn't block the terminal. And then I'll use docker logs-f to view the logs for the container, live as they come in. And the logs look okay. Next, I'll open a new terminal on my home server and try to start up all the containers, including the new FRPC. And as you can see, the FRPS logs say that it just got some new connections from a client, so I think everything is working. Let's confirm by opening the apps in a browser. Boom, there we go. The Traefik UI app and the file browser app are both now exposed to the outside world, accessible from anywhere. Of course, we still see these annoying "your connection is not private" warnings because we're still using Traefik's built-in HTTPS certificates instead of those from a recognized certificate authority, and we're going to fix that in the next step. Next up, we're going to set up proper HTTPS certificates that will be recognized and accepted by most browsers. The certificates we'll use will be provided by a free service called Let's Encrypt, and using them is very easy because Traefik can handle most of the work automatically. I've added just a few new lines. First, you need to give Let's Encrypt an email where they can contact you, so that's on line 31. The next line specifies where Traefik should store certificate-related info, so we'll put that in the ACME volume we created earlier. And line 33 just tells Let's Encrypt to use a specific method to verify my ownership of the domain names that I claim to own and that I'm asking them to certify. I also need to enable Let's Encrypt separately for each subdomain, so each container now has a new label which does that. And that's all there is to it. I'll just go ahead and turn everything off by running Docker Compose down, then run the up command again to restart. And let's look at the logs for Traefik in case anything goes wrong. The logs look okay. I'll try opening the file browser app. Perfect, no more warnings. Let's Encrypt was successfully able to verify that I do in fact own the domain names under imrana.cloud, and they gave me certificates that I can use to enable HTTPS on my websites in a way that will be accepted by most browsers. And the certificates will be renewed automatically as well. HTTPS is one of those things that apparently used to be very tricky to do in the past, but Let's Encrypt combined with Traefik makes it pretty effortless. One more quick thing we should do is enable auto updates for our containers. You see how for the Traefik container, in the image section, I've written Traefik:"latest"? This basically tells Docker to download the latest available image for Traefik. Compare this with FRP, where Docker will always pull down version 0.65 because that's the specific image I've told it to pull. The problem with using the latest tag like I've done for Traefik is that Docker will only pull down the latest Traefik image when it pulls down a Traefik image for the first time because it doesn't have any existing Traefik image. After that, it will keep using that image it originally pulled and it's not going to check for new versions, ever. To solve this, I've added a new container called Watchtower, and you can see the new lines at the top here. Watchtower will check for updates for all containers at a regular interval and update them automatically. Keep in mind that when a container image is being updated, the container will shut down, so you'll have at least a few seconds of downtime for that app. So you may want to disable auto updates for specific containers where not even a little bit of downtime is acceptable. And the way to do that is by adding a specific label to those containers. I've done that to the FRP container just as a demonstration here on line 22, although in this case it's redundant because FRP is hard-coded to version 0.65 anyways. I should mention here that Watchtower is no longer maintained, which I didn't even realize until somebody pointed it out in the comments in my last video. I'm still using Watchtower for now because I haven't found any good alternatives. The top alternative I did find just seems unnecessarily complicated for my needs. One of the things I loved about Watchtower was how simple it was to set up. There is a project called DocCheck that looks really promising. It's the closest thing I've found to a drop-in replacement for Watchtower. It's just that DocCheck itself currently doesn't have an official container image, so I'm just holding off until they get around to that. Alright, we're done. We now have a self-hosted service up and running that's available publicly on a custom domain with HTTPS encryption. From here, adding additional services is just a matter of repeating these steps for that service. You first look up the installation instructions for Docker for the app that you want to install. You adapt those instructions for Docker Compose if the developers haven't already provided a Docker Compose file. You pick the new subdomain where you want your new app to be accessible from. You apply the appropriate labels to the service container in your Docker Compose file. You update your DNS to point your chosen subdomain to the VPS, and then you just run the Docker Compose up command. Now, like I said at the start, this setup as it is now is nowhere near as secure as it could be. Public-facing servers are constantly being hit by malicious bots who are trying to break in and do all sorts of nasty things, and there's plenty that can be done to improve the security of our current setup. So if you want to see the next video where I continue building on this setup and implement things like Authelia, CrowdSec, and GeoBlock, you know what to do.